All right, welcome back, everybody. Today we're going to talk about another section of Chapter 2, specifically the second one. So we'll be talking about Section 2.2, and specifically we'll be talking about errors in measurements. We just got done talking about different types of data and scales of measurement, but essentially now we're going to switch gears, and all measurements come with errors, unfortunately, so that's what we're going to talk about next. Let's make sure we understand that in a little bit more detail. So I asked this question, have you measured anything perfectly lately? So a perfect measurement. And the odds are that you probably have not. Let's talk about that so you better understand it. You might have measured things precisely, probably not perfectly, and even when things are precise, it doesn't necessarily mean they're accurate. So let's make sure we understand what these different terms mean. So remember that precise measurements are not necessarily accurate measurements. Let me give you an example. This is true. I have a digital scale, and it recently said that I weigh 174.25 pounds. I got on the scale again because that seemed odd to me. And again, it said I weigh 174.25 pounds. That's a very precise measurement. So when we're talking about precision, we're talking about a detailed measurement. And I mean, most people, when they talk about their weight, they usually round to probably even like a 5 or a 10. Like, I weigh 150, I weigh 155. I mean, it's pretty rare that someone would say, I weigh 174.25 pounds. That's very, very precise. Well, was this measurement reliable? And it was reliable because it provided consistent results. That's what reliability is all about. When I take a measurement and I get a reading, do I get the same reading when I take the measurement again? Well, in this case, my scale said I weighed 174.25 the first time I got on, and it said the same thing the second time I got on. So yes, it is reliable. So far, my scale is very precise and it is very reliable. Yet, I've got a big problem with this scale. And that's because the next question is it accurate? And the answer is no. It's off by really a relatively large amount. I don't even weigh 150 pounds. So this is not giving an accurate measurement of my weight. In another word, is it valid? Well, if it's not measuring my weight, then this measurement scale, this bathroom scale that I'm getting on, is not valid. Okay, so when we ask a question about is a measurement valid, we're asking, does it measure what it's intended to measure? And in this case, the scale is intended to measure my body weight, and in this case, it is not doing that very well. So there are clearly some errors associated with this measurement. Let's talk about these errors because they come in two flavors, essentially. So is the scale producing random errors or what we would call systematic errors? Random errors are really mostly unpredictable. So I would get on that scale and it would tell me I weigh 130. I'd get off, I'd shake my head, I'd get on again and it would say 174, and I'd get on again and it would say 142. Bottom line is there would seem to be no pattern. That's a random error. Random errors are actually pretty common. In a scale, we wouldn't usually see that much fluctuation, but you probably see this relatively consistently at your own home. You might get on a scale and you're reading the dial as best you can, and it might say 150 pounds, and you kind of look at it a second later when you moved a little bit and it might say 151. There we're just talking about some random error. Systematic errors reflect consistent problems with the measurement. Let me show you a graphic that explains this pretty well. My scale had a very systematic problem because it kept telling me that I weighed 174.25 pounds, and let's say I weigh 150. It was essentially off by 24.25 pounds each time I got on the scale. So it's kind of like this image right here, where when there's nothing on the scale, it already says 1.2. So this would be a good example of a systematic error. Everything is going to be off by at least 1.2 pounds if the scale is starting at that point. But now here's what I was starting to mention before about random errors. This is very common, particularly when we're measuring something that's alive, like a human being. So if we're trying to measure this baby, the baby's going to be moving around a little bit. And as the baby moves around, as the baby even breathes, the scale is going to be changing its value just a little bit. So sometimes when we measure a kid, we're going to get a weight that's a little bit low. Sometimes when we're measuring a kid, we're going to get a weight that's a little bit high. Sometimes we're going to be right on target. But do you see how those are relatively random errors? Those are errors that in general we'd like to reduce, of course. We always want to reduce errors. But we can usually live with these random errors if our measurement devices are reasonably well created. These systematic errors are very different, particularly when they're large. We really want to identify those because they won't cancel out in the long run. In the long run, we're going to find some babies that weigh a little bit more, some that weigh a little bit less because of random fluctuations. But if we're weighing babies on this scale, they're always going to come out at least 1.2 pounds heavier than they would be otherwise. So that's the difference between random errors and systematic errors. All right, well, let's kind of quiz you a little bit. Let's say your group is working on a survey to assess students' diets. And among other things, you ask your respondents to report how many grams of protein they consume in a typical weekday. The survey requires them to enter an exact amount, like 25 grams of protein. Comment on the precision and expected accuracy of this measurement. Well, think about it. If we're asking students to report how many grams of protein they take in, that's relatively precise. I mean, if you ask me how much protein I take in general, I have no idea. I might tell you like, well, I eat a couple eggs and some turkey and, that's quite a bit of protein, I think, overall. I have no idea about the grams of protein. So that measurement that you're asking for, how many grams of protein do you take in per day, is really quite precise. However, just like I said, I have no idea how much protein I'm taking in. So do we expect that it's going to be accurate? I don't expect that it would be accurate at all. Maybe if I'm dealing with nursing students or dietitians or something like that, and I'm asking them how much protein they take in, they might have a good idea, but the general public's going to have really no idea. So just in general, the scale is relatively precise, but we should have little faith in its relative accuracy, because most people do not know precisely how many grams of protein they typically consume. There's really no way that they're going to be able to report that. Okay, so we're getting comfortable with some of these terms. Now let's discuss two ways that we can quantify these measurement errors. Now that we know some basic terminology, let's see how we can quantify and actually capture how much error we have in some of these measurements. First, let's talk about absolute error. It's really very straightforward. It simply describes how far some measured value is from its true value. All right, so we can look at this equation. It's very straightforward. Absolute error. So when we talk about absolute, we're talking about the absolute amount, the actual amount of error there is in a measurement. So it makes sense that we would take the measured value, like how much did we measure the value to be, like my weight, for example, and what's the true value? So just to kind of talk our way through the first example here, my scale measured me to weigh 174.25 pounds, but I weigh 150. So the absolute amount of error would be 24.25 pounds. All right, let's go through an example a little bit more formally. On average, let's say your respondents report consuming 30 grams of protein daily. And let's just say that some research exists out there where people use food diaries and they actually report what they eat so that we can calculate exactly how much protein they take in, or not necessarily exactly, but we have a really good idea of how much protein they're actually taking in because they're reporting the food that they're eating. And let's say from that research, we find that people typically consume about 50 grams daily on average. So I know this is a contrived example, but I just want to go through a relatively straightforward example so that we can see the math involved. So based on this, estimate the amount of absolute error. All right, well, let's talk about this. So the absolute error in this case is going to equal the measured value. So our respondents reported consuming 30 grams of protein. We know that in general, people are eating about 50 grams of protein based on prior research. So when we take 30 and we subtract 50, we find that they are underreporting their protein intake by about 20 grams. So respondents probably really did not estimate very accurately how much protein they were taking in. Let's take a look at how this very simple formula is set up for just a second, just so we understand what's going on. Sometimes students get confused, do I take the measured value and subtract the true value? Do I take the true value and subtract the measured value? Like, does it really matter the order? in which we do that. And it does, and this is why. If we're always subtracting the true value, then our value will come out negative when our error is essentially in the negative direction, in that, in this case, like people were underreporting how much protein they take in. Let's say the people were over-reporting and they said 100 grams would come out with a positive number. So the positive number would show error in the positive direction, and that they are over-reporting how much protein they were taking in. So it's very important that we take our measured value and then subtract the true value. Okay. Let's talk about relative error. Relative error is another way to talk about error, and it kind of puts things in a ratio type of format where we are comparing the size of the absolute error relative to that true value. So how much is the error relative to the actual true value? And this is how it would be expressed. We would first calculate that absolute error, and we'd simply divide by the true value of the measurement. It's that easy. Now we're left with a ratio. It's going to typically be a value that is less than 1 or slightly over 1, something like that, depending on the error. And then we multiply by 100 to kind of make it as a percentage, just so it's a little bit easier for people to understand. We tend to understand in our country and in our world, I think, proportions not so well, but percentages very well. So we multiply by 100 as we express it. So here we go. Let's give a little example here based on what we had before. On average, your respondents report consuming 30 grams of protein daily. Again, there was research with food diaries that showed that people consume about 50 grams daily. Based on this, estimate the amount of relative error. All right, well, let's remember how this equation works. Relative error is going to equal the absolute error divided by the true value. So the absolute error is going to be 30 grams minus 50 grams. And then we want to divide by the true value. And the true value, based on the previous research, is 50 grams. So we have 30 minus 50 divided by 50. Okay, so it's not too much more complex than what we dealt with before. Let's just work that out real quick. I'll bring up my calculator. So we would have 30 minus 50. So again, we knew that there was an underreporting of about 20 grams on average. And I'm going to divide that by the 50 grams. That equals negative 0.4. So that's the proportion I was talking about. And people in our world don't understand proportions real well. They're directly related to percentages. That's why we usually multiply by 100 to get a percentage. So I'm going to multiply that real quickly by 100. And we would find that our final answer is negative 40 or negative 40%. All right, let's go through another example. So let's compute the absolute and relative error in this example. The sticker on a car states that the car gets 22 miles per gallon highway, but measurements show that it actually gets 24 miles per gallon. So we can see that our measurement is 2 miles per gallon off from the true value. Well, that's what the absolute error is all about. It's really that straightforward. So remember, we're always going to start with our measurement. We're going to subtract the true value, so we can see that our measurement was 2 miles per gallon too low. All right. Well, in order to compute the relative error, we want to look at that absolute error. So how much was our measurement off relative to that true value? So we compute a ratio of the absolute error relative to the true value. So in this case, we're going to start off with that absolute error of negative 2 miles per gallon divided by the true value of 24 miles per gallon. All right, let's just use our calculator real quickly here, clear it out. So we would have negative 2 divided by 24. That equals 0.0833. And in general, when I do things with you in class, we just kind of take things just one step at a time, just so we're all on board and we all understand what's going on. And sometimes we just kind of round as we go, just to keep things simple. So we're essentially dealing with negative 0.08. And we want to convert that into a percentage by multiplying by 100. So I'm going to multiply that now by 100. And of course, that comes out to negative 8%. More specifically, negative 8.33. But we'll just keep things simple for right now. So negative 8%. All right. So how can we kind of draw a conclusion here if we wanted to sum things up in a quick sentence? The sticker rating was 2 miles per gallon too low, which is an 8% underestimate. That's about it when it comes to these absolute and relative errors. They're all going to work in the same way. We just need to make sure that we're subtracting things in the right order, so that negative values are going to show that our measurement was too low. Positive values are going to show that our measurement was too high. And then we just create a simple ratio, multiply by 100 to convert it into a percentage. All right, they're all going to work exactly the same way. Just another couple quick points before I let you go. By the way, to compute absolute and relative errors, we need to know the true value, right? Because we're taking our actual measurement and then subtracting the true value. Although we often know the true value of some measurement, like eventually, we often know what that true value is. Sometimes we need to estimate that value, like we did in that one example about how many grams of protein people take in daily. And thus the estimate, and thus we estimate the size of any measurement. And really that is just the way things work. We just do the best we can. We do not always have a true value. So sometimes we just estimate it, and that means our errors are estimated errors in reality. So for example, is it likely that you'll ever know the actual amount of protein that your respondents consume daily? You're not going to know that, are you? So you can ask them all the questions you want, and we can kind of estimate how much error might be in there, but we're probably never going to really find out how much protein our actual respondents take in. So some of this is somewhat theoretical. We can't always compute these errors. So here's a real quick summary of what we just went over. If we're not careful, there really is lots of room for error in our measurements. And then even when we are careful, complete accuracy really is very hard to achieve. We almost never have a completely accurate measurement. But in general, there are just two types of error that we need to worry about: random error and systematic. Make sure you know the difference between them. Also make sure that you know how to compute absolute and relative errors based on the formulas that we just talked about. They're relatively straightforward. And we need to make sure that we understand the differences between those as well, because when they are reported in research studies or in the news, we have to have a sense of what's going on, because those values will obviously differ. So we have to get good at determining if we're dealing with a relative error that's reported or an absolute error that's reported. We'll talk more about that as the semester goes on. That really is the key content from section 2.2. So for now, that is all.